Super. So let us go ahead and get started for today. We got a lot of exciting stuff to cover today. We're going to be looking at really continuing with the example we started last time of building a parametric stadium out of some elements that combine together using some scripts. Okay, we're also going to head into a new area. We're going to finally get into optimization and really how we can use the scripting language to evaluate a lot of options and return some values from the Revit model so that we can then consider, what the impact of these different options are and hopefully kind of choose a strategy for narrowing down the one that we think is going to be, the best choice. So we're going to start down that path too. Okay, in terms of just some recap stuff to go ahead with, assignment 2, most of you know, is due today, so hopefully you're in good shape with that. I'll actually start by kind of answering a question from one student, Alan, who actually asked a very good question about the assignment in terms of how we could create surfaces using different forms. But in general, you just need to know that it's due at the end of the day, so please go ahead and get that turned into your coursework Dropbox. Okay, looking back at where we were last time, we went through and did a lot of mapping of colors to different panels. So we were looking at images, pulling color out of those images, and then either just mapping that color directly to different panels or taking a look at the issue of the brightness and using that to go through and determine the height. Now, most of you know after session 9, okay, we posted a correction to the video because in terms of the scripting, I was looking at things a little bit incorrectly about how to break down the list and slice it and chose the wrong grouping, and that created a problem. So the videos are corrected. I apologize for that mistake. Raj actually caught it, or not Raj, excuse me, Pratush caught it and just let me know, and we got it all corrected. So hopefully it'll all make sense if you either look at the videos or any of the example files. They've all been corrected too. So yeah, you should be able to kind of use those. Okay, we then went ahead and took a look at really this whole issue of a stadium and defining some arcs that define the shape, placing some ribs or defining some rib lines and placing trusses on them. And that's pretty much where we left things. Ultimately putting in a switch to control whether or not the Revit geometry was going to be created. And that's kind of where we stopped. We're going to keep on going with that as we go today with building out some more of that parametric stadium, thinking about how we put risers in it, ultimately put panels all around the outside of the stadium. So that's where we're really going today for the first part of the class. Okay, before we go there though, I did want to go ahead and answer, it's really Alan's question that has to do with really this whole notion of how we create surfaces, because I think it's actually one of the more confusing aspects of all the scripting is really what can you create in different environments, because there are limitations. In the Revit environment, we can do things like create panels, adaptive components that follow different XYZ points that we give it, so different coordinates. Okay, but the whole notion of can you create curves or can you create surfaces by lofting curves together, that's something you can't do directly in the Revit environment. And we have to resort to a couple of different forms, either creating things in a family, and we can do it in a generic family or any family type. We can actually create curves from points in families. If we want to go through and actually take those curves and loft them into a surface, we actually have to do that into a conceptual mass family, because that whole notion of taking curves and lofting, using them to create forms is really only available in conceptual masses. Okay, so that's where I'm going to start. And before we head off there, let me just go ahead and kind of check the chat window, see if there's any questions so far. We're looking pretty good so far. I don't see anything in chat, so let us go ahead and launch on down that path. And to do this, I'm actually going to go through and just really illustrate it with Alan's file himself. He actually sent the file. So Alan, thank you for sending that. There's hopefully nothing too awfully proprietary in this, but we'll just take a look at it. Oops. I think maybe there is a question. Nope. Okay, looking good. So what I'm going to do is actually open up, and I'm going to go to that session 10 folder. If you haven't opened it yet, please do just from the coursework website, go to session 10. Let's take a look at the Dynamo examples in there. And I'm actually going to start with the 10.0 Allen surfaces and take a look at those. So within this, Alan actually went through and created just a Dynamo script file, and I created a couple of Revit files of different types, a conceptual mass family, a generic family, and a surface panel project, a project that has a lot of surface panels. Let's take a look at it. Okay, so Alan actually created a very interesting form using sines and cosines, and with the final form placed, it looks something like this. So that's a pretty interesting wall surface. Okay, just using a combination of sines and cosines. Let's take a look at his scripting and kind of see how he went ahead and did that. So I'll open the Dynamo plugin, open in turn his scripting. Let's see where I left that. I think I put that in session 10. Okay, and his script is right here, surface allen.dyn. So let's take a look at really what he put together. So it all starts, back over here in terms of, zoom out a little bit. Kind of creating a grid. He's doing it by kind of putting a lot of points. He actually has 100 points in there, or it looks like I have it currently set to about 35 by 35 points. He's computing some X and Y's. He has an interesting formula right here, okay, for actually computing the height at all those different points. And then actually applies a scale factor, which makes the thing bigger, smaller. So does a really nice job of sort of putting that all together. The question became really what to do with all those points in terms of trying to create a surface. And one strategy is if you want to create just adaptive panels in Revit directly, so in the Revit project by using those points, we use this quadding function, the quads from rectangular grid that'll go through and take those rectangular points and group them in fours that we can use to then place adaptive components. Okay, and from that, the way to actually make that into the Revit families, and actually place the Revit adaptive component families, is to select the family type and then say just adaptive component by XYZs. Okay, and it's really just using that little chunk of script right in there, taking his quads, because Alan got it right to here, and then just taking the family type and just placing them based on those XYZs. That's how we actually got the surface. Kind of hanging out back there in Revit. So those are all just a bunch of individual family points. Each of those is just a rectangular seamless panel, has some properties, placement points. Okay, the only sort of variation on that that's a little odd is I put this little Boolean right in there just to control whether that thing regenerates, because there's a lot of points in it. It just takes quite a while. If you want to generate that, you'll see it actually takes a fair amount of time. So that's the path we follow when we want to go through and just create something directly within Revit. Okay. The other way, though, that Alan started heading down, which is a very good approach, is to say, hey, I have all these different points. Let me go ahead and try to make some splines out of it and some reference curves. Okay, and again, that's a very good approach. It's just another way to approach it. The idea of creating curves or just using those points to place the panels directly at the XYZ points. It's really, you could go either way. It just really depends on what you're trying to do. But let me show you how this works in terms of actually creating that. The deal is you cannot go through and create this like in the Revit project. Let me make sure the geometry creation is turned off. It is. And let me try running this and show you that what will happen is you'll get an error. We're good up to the point of getting the splines, and if I Control G, I can even kind of show you that Alan created that fantastic looking surface here, and that's just existing in the Dynamo environment. Okay, but the point of actually creating the reference curve is where we get ourselves in trouble. And it says that this operation is only permitted in a family document. Okay, and that's because you can't just go ahead and place the curves directly in Revit. What you actually have to do is put them in a Revit family. Okay, so let's go ahead and take a look at what that looks like. Okay, because, it's just something that's not going to work within the Revit project, but we can do it in a different environment. You'll see loft service is also kind of not working right now. We're going to find out that that's only available in a specific type of family, a conceptual mass family. So let me close that for right now. And instead, I'm going to go through and open up new family. Okay, I'm just going to make this a generic family. Generic model. Could have been any other type too. There's nothing special about generic in terms of doing that. I just rotate that to 3D. Not much that you can see there just yet, but let me go back into the add-ins, bring up Dynamo. Actually, the truth is, I didn't need to go through and close that. It's really, Dynamo tried to act on the, whatever the active document is. So the one that's kind of at the top of the heap. Okay, so once again, we have his scripting all hanging around in here. Let me try running it. Okay, and this time we got a little bit further. Okay, it's going to complain up here that the adaptive components aren't happening. That's because we have the Boolean turned off. So that's what's sort of upset there. Also, the family type's not available within this other family. But the whole idea of the splines generating the reference curves, it looks like it actually did that. We have a bunch of splines that are kind of hanging around over here in the Dynamo environment. And if we come over here, let me zoom on out. There you go. You can see he has all his curves. There's a whole bunch of reference curves that are defined by those different points through the spline. Okay, so now we have a bunch of curves, and if we want to use those, that's a family. I can then import that family. I can load it in my Revit project and use it, okay, or do some stuff with it just here within the family. Okay, but in a family, a generic family, this is as far as we get. We can create the reference curves. We can't loft the surface. It says this is not permitted in this type of family. So it turns out lofting the surface is a special type of family. That's only in a conceptual mass family. So not to worry. We'll go ahead and keep on going. We'll say, well, if you don't like that, let's see what else we can do. Let me open up a new, in this time, a conceptual mass family as opposed to the generic family. Okay, again, let's see if we can bring up Dynamo and make this work. So in this case, I should be able to get the curves. Those curves will place just fine into the conceptual mass family, but hopefully we'll get that next step. It's interesting. Looks like maybe I do have to close it again. I thought that it would just adapt. I guess it adapts to the newest window. But, try just reopening Dynamo within this family. There's just confusion about which family it thinks it's associated with. Okay, again, same script. Haven't really changed anything here. Let's just try running this. Okay, still complaining because this family doesn't have the adaptive component in it. But over here, you'll see that we actually have now not only the curves, all those different curves, but we actually have a surface. Okay, now, what can you do with that surface? If you want to go ahead and panelize it, what you can do is just load that in to Revit, okay, and select that surface and divide it up into X, Y, Z's. And, that's a perfectly valid way to do it. Since you've already divided up some X, Y, Z's over here, in terms of how we even generated the curves in the first place, you don't need to do that. But I guess the point of all this is that really there's a lot of different paths that take you to the same location. And you just really got to figure out what is the path that's going to be the best fit for what you're trying to accomplish, whether it's just to work directly with the X, Y, Z's, or use scripting to generate a form, which is really just kind of a convenient way of encapsulating a lot of X, Y, Z information into a surface. Okay, and then start subdividing the form. But ultimately, you sort of get to the same place, whichever way you go. So let me pause there for just a second and see if that makes any sense or has confused you hopelessly. In terms of either going directly from Revit, going through a generic family, which lets us get the curves, or a conceptual math family, which actually lets you loft the surface and use that. So I'm going to pause for a second, see if anyone has any questions. And if you want to type them in or jump on in, please do. Okay, Raj and Pratush, I'm going to look to you to kind of affirm whether you think the class is ready to go. No questions? Perfect. Okay, thank you. We're ready to go then. Super. Okay, once we're past all that, let's return to the example of this parametric stadium that we were building, because it's kind of a really cool stadium, and keep on going with what we wanted to do. Where we left off last time is we'd actually gone through and placed a lot of just beam elements or truss elements based on some different arcs. Let me kind of open that up, and then we'll keep on going from there. Okay, so we'll go back, but really the path for what we're going to do today, just so you get a sense of really what the overall script is similar to what we did with placing some arcs that we used to generate the surface on the outside. We're going to create a series of different arcs that are going to represent these different risers, different steps, okay, for placing seats. Put some points in there, and then place some risers on those, and then start worrying about that surface. Okay, so let's just kind of go through there and kind of think about each of these different sub-steps. In some ways, placing these arcs for the risers is pretty simple. We just have the origin. We're going to put some slider in there for what the radius is, and then generate a single arc. Then to create multiple arcs, we're just going to have a number slider, which, based on the tread height, the tread depth, and the number of risers, is going to create a whole series of different arcs. Okay. Then we're finally going to start subdividing that arc, those arcs, up into a whole series of points. Okay, and then going through and placing some riser elements on that. So let's see if we can kind of walk on through that. Okay, so coming back over to Revit, let me close up Dynamo. Say no on some of these changes. And then finally, I'm going to close up this nice surface, only because there's a lot of data in that surface. That takes a long time to recompute. Okay, and let's go back in. I have that stadium. Kind of open that up. And we'll start with the example 10.1. Okay, just so you get a sense of where we're going to tonight, here's today, excuse me. Here's the sort of finished effect that we're going after. We zoom on in there. I have the stadium itself that has a whole series of these different trusses. It has, these are the things that I call the risers. Okay, and these are the panels that are all around the outside, and they're responding to a couple different things. They're responding to color, and they're also going ahead and responding to, or giving us color. They're also, the size of the openings is also responding to the sun. So let us figure out how to go through and generate this. Okay, to get going with this, really what I'm going to do is actually just, I'm going to take out all these so we can regenerate them. Just so I'm starting relatively cleanly. Let me just kind of make that shaded, and I'm even going to turn off the sun for right now. We don't need to have it on for right now. Okay, but let's open Dynamo, and we will start rebuilding this thing again. So under Manage, not Manage, excuse me, Add-ins. Let's take a look. We'll open up, and within here, we'll go again to session 10. Okay, under this, where are we starting? We defined the arcs, we defined the ribs, we placed the trusses, we added that rebuild switch. Let me go ahead and just do that, just to refresh us. So we divided all those things up. We went through and ultimately placed these adaptive truss components. Let me say update the geometry once so we can get those trusses in there. Okay, over here, let me Control G just so we can sort of see the little preview of what that looks like in the background. Okay, and I think this is where we'd sort of left it last time. We have those different trusses, so let's keep on going. Okay, as we go through and try to create those risers, what we're going to do is actually just put a couple of arcs in down at the bottom, and I'm just going to build it up a little bit at a time. First step is going to be just to place a single circle down at the bottom, or a single arc, because we want it to sort of follow the same sweep as the outer surface. So how about this? Okay. Not too much going on just yet, but let me go ahead and run this. See if we can figure this out. Oops, I'm still in the environment. That's why I'm not moving around in here. So we went through and set up a series of different radiuses for riser arcs, or the riser arc 1 radius, I should say. That's for the first arc. Okay, there's a tread depth and a riser height. Those are some variables we're going to use, and a number of risers, and we're going to wire this all together in this way. We're going to use that riser arc radius to go through and create an arc by center, radius, and parameters. And then what we're going to do is go through and, based on the riser tread and the riser height, just go through and add some things together. What we're going to do is basically add that height, okay, and then go through and create a whole series of different heights, okay, based on the number of risers that we want to put in there. And then we're also going to create a series of different riser treads. Let's go ahead and run it and show you how it all works. So if the riser arc radius is 43, okay, riser tread depth, let's go ahead and take a look at this. What I'm doing in this formula here is just going ahead and taking that height, dividing it by 1 foot. Hang on here. Why is it showing me 0 there? Arc radius, XYZ 0. Now it's just the origin. Oh, we're taking 0 feet, we're dividing it, that we're just getting 0 to just be the origin of all that type stuff. So we're going to start a sequence at 0. So in terms of the riser heights, here's what it's going to look like. We're going to get some different heights, 0, 2, 4, 6. Why I'm getting that is, I basically said there's 4 risers, the heights are 2 off. So I'm getting 2, 4, 6 as the heights. In terms of the treads, let's take a look at that. I'm getting 43.4, 45.5, 45.9, 48.4. What that's all about is I'm just starting with 43.4 as the first one, and I'm adding a whole series of 2.5s. So for each of those different things, I have a starting value, I have the amount that I'm stepping it, okay, or the number, and then the step increment. So that's how I'm getting these 2 different distances, 2, 4, 6. Okay, pull that all together. Okay, and out of those different things, we are now ready to start linking it back in and creating some more arcs. Okay, we have the first arc placed right down there. Let me kind of zoom in on that. Can you see it? Control G. This arc right in there, that is the arc for the very first riser, but we don't have all the different arcs placed yet because we haven't actually used that sequence. So let me go ahead and open up the next one, which actually has that in place, which is under step 6. Okay. From here, all we've really done is we've taken all those different riser heights as Z values. Okay, as we're changing the center to be the center of each of the different riser heights. And then we're creating a whole bunch of different radiuses, okay, at each of those different heights based on this riser tread radius. So we want to create something that at height 0 is going to have a radius of 55. At 2, the Z of 2 is going to have a radius of 58. And at a height of 4 is going to have a radius of 60. Okay. And how we do that is we just feed all that into the arc radius, centers, and the radiuses. Start and end of the radius is just 0 up to the sweep distance. Okay, so you can see it's actually created 3 different little radiuses back in there. Okay, and we can control that just so you get a sense of all that. If I want to have more risers, let me just turn this on and let it run automatically. You can see it can add as many risers as we want to. We don't have any geometry yet, but we have the number of risers. And if you want to control either the slope to make it a steeper bowl, I can make the riser height taller. It's steepening it. Or if I want to flatten it, I can also go ahead and expand the length of the tread depth, and it'll spread out a little bit further. Okay, but all we're really doing is creating a lot of different little radiuses for us to work with. Maybe it's a little bit easier for you to see it there. Now, what we would like to do is actually use all those different radiuses to go through and place some geometry in here. Okay, so how are we going to do that? It really is as simple as this. What we're going to do is say that, hey, we actually have an adaptive component for the risers. Let's take a look at it again. Looks like this. Kind of this little L-shaped profile. It's got 1, 2, 3, 4, 5 points. So in order to use that, what we need to do is just break that arc up into 5 points so that we can use those 5 points for placing this. Okay, so to do that, we'll go back over to Dynamo. Hang on just a second here. What we're going to do is take all these beautiful arcs that we've created and we're going to subdivide them by one of these X, Y, Z's equally spaced. Okay? And to do that, we can say X, Y, Z. Or actually, what is it? Is it divide equally spaced X, Y, Z's on curve? That's what I want. I'm going to feed that a bunch of curves. So it's going to take all those curves. We have to say how many different spaces or how many points we want there. That'll just be a number. In this case, I don't want to put a slider in there because it's actually a fixed number. It is 5 points. Feed that out in here. You'll notice it put 5 different points over there. So now we're ready to start placing all the different adaptive components using those 5 different points. So how does that look? It looks just like it worked when we put the panels in there and the trusses. It's select family, type, and we need to choose the riser family. Once we have that riser family, we are now ready to do this adaptive component by XYZs. So I need to take my riser family, these XYZ 5 points, hopefully they'll correspond to each other. It's doing a little running in the background right now. I might want to put a Boolean in here to slow that down or to stop the regeneration of the geometry. But if I come back over now, pull that up to my Revit project, okay, you'll see that I actually do have all those little risers in place. Let's just take a closer look. Okay, super. So we should be able to control this. In the same sense, if I want to go through and, for example, that's the riser arc radius, there's the tread depth and the height and all of that stuff. If I want to put in kind of, let me make those a little bit shallower, I can do that. If I want to make them a little flatter still, it's recomputing that. If I want to turn down the number of risers, or turn up the number of risers. Okay, we're having this ability to parametrically go ahead and control that. This is just putting the risers in there. We could also start thinking about placing seats on the risers. Okay, but this will go ahead and get us started. So let's pause for there for just a moment. We've created multiple arcs for the risers. Okay, we define placement points just by equally dividing them into XYZs using an integer slider. Actually, in this case, I didn't use an integer slider. I actually used an integer. Because I actually had a fixed number of points that I wanted to actually use, which was the same number as mismatching of the riser itself. Okay, then we place these riser elements by using the adaptive component. That's one thing I did not do. Let's go ahead and talk about that. If we want to go through and actually control the tread depth and tread height, you'll notice that over here I have these little gaps kind of hanging around in. Kind of make that a little bigger so you can see it better. I have little gaps in my scenario because I've defined placement curves, okay, to go ahead and assume the right height and the right thickness, but I haven't actually adapted the adaptive component to adopt those. You'll see that each of these different risers has two different instance variables available to it, type parameters available to it. It has a tread height and a tread depth. Okay, so I do want to go through and change those two things so that they match. For example, if I want to make sure that the tread depth is actually the full distance, and I don't leave that little gap that people could fall through, okay, here's what I got to do. Let's come back over to Dynamo, clean that up a little bit. I got a really good looking script over here. It is just looking fine in terms of placing all those elements. I just need to add a little more to it. So here's the place where we create all the different elements. These are all the riser elements. We now need to go through and just add some things that are going to control its parameters. And there's a couple different ways to do that. We're used to the whole select or set element parameters. Okay. And that is a perfect one when you actually want to set the properties of a single element. So if we had an instance, and this was an instance parameter, that's how we do it. That's not actually what we have here. What we have here is actually a family type parameter. So it's going to change all of them. We're going to use that function instead. Okay. So what we need to do is actually go through, and this is a little grunky in terms of thinking about this. We aren't actually going to go through and plug the individual elements through. that would be this one. We're actually going to go through and take the family type. Okay, and we're going to feed it a string. Something like tread depth that matches the existing. And we need to give it a value. Now, as we think about this, we actually do have a value. It just happens to be hanging over here. We use the value to go through and compute where the placement point should be. So if I can kind of string that over right there. Okay, what it's doing is doing a little regenerating because 4 of those different treads would have been placed within that family type. Okay, and it sort of spread them all out there. So now the depths are right. And we can do the same sort of thing to the heights. So depths and heights, we can go through and control all that stuff. Okay, let me pause there for a second because we've sort of played around with all these different variations on a theme in terms of placing the riser elements. I then want to start thinking about panelizing this thing. But before we go down that path, let's just pause for a second and sort of see how people are feeling. Saraj and Pratush, can you sort of get a sense of the room and see how people are going? And again, all looks good in 184. Super. How about anyone online? Are you guys feeling good? If anyone has any questions, just go ahead and ask. Okay. If you guys are feeling good, let us go ahead and continue. Okay. Next thing up in terms of just trying to complete our stadium is we really want to start thinking about, just how can we go through and just put some panels on the outside of these things. So we're going to think about applying some adaptive panels. Okay. Then going through and just placing some panels. What we're going to do first is basically take those truss curves and then we're going to apply some adaptive panels to them. So let's go ahead and kind of take a look at this. Okay, we need to basically think about, for these truss curves, how many different points we want to break them into. So, and then based on that, we're going to put some panel scheme in here. So let's just kind of go back to the truss curves and see how we want to approach this. Let me Control G out of here so I can see that preview. I'm going to push the scripting out of the way so you can sort of see better. So here's the deal. We have all these different trusses and they're defined by these 4 different curves. Okay, and if that's what we wanted in terms of panelization, we could go ahead and place panels based on those 4 different curves. Chances are, though, we actually want to put a finer grain in there. We actually want to divide things up into more points than that. So, for example, for each of these different curves, I could go through and break it up into 5 or 6 or 7 or 8, just more different points that will then give us the ability to kind of more finely place the panels. Okay, so it's all about just giving ourselves more panel points to place. So 4 is feeling a little bit gross right now in terms of not giving you enough control. Let me go ahead and open something else. And that will be in the hierarchy of all these lessons stacking up. It is dividing the truss into more curves. Okay, so here's what I had in mind. Is to actually go through, and I have all these different curves. Looks like it's doing a little regeneration right now in the background there. Okay, I have all these different curves that came out of those Hermite splines. Okay, and what I want to do is actually just go through and say, how many panels would I like to have on each of the different truss columns? I set myself up with a little slider, a little integer slider, so I could control those. Okay. But the only thing I did beyond that was I said, okay, if I want 7 panels, I need to have 8 points. So I'm just going to add 1, so number of panels plus 1 gives us the number of points we need. And then I'm just going to say equally divide those curves by that count to give me a whole bunch of X, Y, Z. So let's just kind of see that in operation. If I can push that little preview up here a little higher. Let us go through and try sliding that around a bit. So you can see if there's 5 panel points, notice my panel point here isn't the same as the point that was used to actually define where the truss, control points would be. So I have 1, 2, 3, 4, 5, 6. There's actually 6 points that are used to create 5 different panels. And if I up that, you can see I'm just subdividing it a little more finely. Okay, super. Once you have those points and you are ready to go, okay, by saying equally spaced X, Y, Z's on the curve, okay, I need to do just a little bit of an operation on them because all those points are really in a whole series of different lists. Okay, each of those different lists is the list of points on each of those different curves. So there's a series of different lists, each of them representing each of those different curves. What I want to do is flatten that out just so it's a big list of points and just reverse it. And this just has to do with the directionality in terms of I just need to kind of flip the entire list from top to bottom. So the reverse is just going to flip all the points around. And I won't get into the details of that just now, but it's going to help us with actually placing the panels. And then out of that, what I'm going to do is take that big old list and say, let's break that into quads. So what that's going to do is take 1, 2, 3, 4 points, actually put them in the right order for how we want to form the quads. So 1, I get 2, 3, 4. So that we can actually create these different quads. And that's what we're doing in terms of just ultimately breaking things up so that we get a series of different quads that we can use to place the panels. Okay, once we have those quads, you're golden at this point because you just want to place some panels on top of that. And you know how to do that. We can again select family type. This time we're going to use, one of those panels, and I think the panel that's loaded into the project right now is the one that has a little insertion hole, the hole that can adapt the opening based on some parameter we give it. We're going to say again, what is it? Adaptive components by XYZs. And we're going to feed it the panel and those XYZs. And with any luck, it'll generate and kind of create those for us. And this is just like what we did with Allen surface a little while ago. It's just if I can make a series of curves, kind of turn those into quads, then with any luck, hopefully place a lot of points. Okay, let's see how it did. Looking a little close in there. Looks like my risers right now are actually kind of poking outside my stadium. I didn't really put any kind of control on that. So that's what's going on there. I should probably kind of fix my riser depth of the number of risers so it stays inside. But here are all the different panels. Okay, and as you can see, it's gone ahead and created the panels all the way down using those control points. So again, each of these different quads of 4 is really mapping into panels that look like this. And this is okay. This is not too bad. I could change the number of ribs to kind of make those a little bit more fine. Yeah, they're kind of very big panels right now. It's not very curvaceous because those panels are pretty much flattening themselves out between the 4 different points. Okay, so that's not really giving us much control there. If I wanted to go through and give myself a little more control, I could go through and either add, okay, I could either go through and add more ribs, okay, which would then break it all up. But I was actually thinking about doing something a little bit different. Anyway, let me pause there before I go to that next step and just, again, stop and see like if there's any questions about that. So just dividing the truss points into panels, so an even number there, and then applying the adaptive panels. Okay, so Raj and Pratoush and anyone online, just go ahead and like give me any feedback about whether that part sort of made sense. The good news is all these examples are kind of hanging out there in a very stepwise fashion, so you can go and kind of replay any of these and at any point kind of see exactly what the differences are. So any questions or any feedback? What do we think? Okay, sounds good. Thank you, Raj. Okay, the next step is really, if we have all these different panels, could we actually start dividing the panels up a little bit to go even a little bit one step further? And let me kind of tell you what I have in mind. So here I am kind of hanging around. We got to bring that scripting up here again. And, oh, that's going to pull this out of the way. So the idea is as follows. Control G, just so I can orbit that thing around. These splines are the ones, these ones that are kind of currently here. Those are the ones that I'm using to go through and place the trusses. If I actually wanted to think about breaking down more panel points between the trusses, what I could do is actually just sort of create a whole nother set of splines. Okay, that'll really be the panel seams as opposed to the truss locations. And in terms of doing that, that's actually pretty easy. You know, I just went through and broke down number of ribs and equally spaced on the different arcs to create those, and then did a little transposing to make those splines and all that kind of stuff. I could go through and just create a whole another set of splines, okay, and just subdivide that thing even further. And I can do this a couple different ways. I create a whole second set of splines and just kind of pick from that list. I could just sort of expand the number of splines in the first list and then just only pick every third or fourth element. You know, again, there's a lot of ways we could approach it. But what I was really looking to do is just sort of subdivide so that I have another set, which is going to be the panel locations. Okay, and let me kind of open that up and kind of show you what it looks like. So if you go on down to dividing panels between the ribs, step 11, it's doing a little recomputing in the background. Doing a lot of recomputing in the background because I actually have quite a few panels in here. I should probably put a buoy in here to control whether or not it does generate it. still going? Looks like it's still working in Revit in the background. Okay, let's take a look at what it did. In my new improved version, oh, that's interesting. I still have the old ones kind of hanging around in here too. I should have, I should learn to delete. Can you see the old panels still hanging around back in here in the background? I'm just gonna get rid of them. Oops, looks like I got rid of the wrong one there. We'll regenerate this at the break, so we can kind of like do that for everyone. But let me just kind of show you the general principle of what we're after. The idea here is I've created a whole another set of splines that also has the same number of points on them. So how is that really happening? Say those are the risers. That's all riser land. Let me go up to the top here. Number of ribs is right in there. We're just kind of breaking up the number of ribs by, or these arcs by the number of ribs, and doing this whole thing where we do these splines based on that to get the rib locations. But what I've also done is set up another one just for number of panels in each row. So I have the number of panels between the trusses. Okay. What I have to do is actually take the number of panels. Yeah, ultimately what I had to do is really kind of do a little computation, because what I had to figure out is, just really how many splines to generate. Okay, so if I was going to go through and create 4, what I really need to do is create 24 different spaces. And that was based on the number of ribs minus 1, okay, which is actually the number of panel sections, by the number of panels within each of those different columns that we're subdividing. So I apologize, that's a little messy. Let me think of it, make more sense of it. If there were 8 ribs, that meant there were 7 sections between them. That's what's multiplying this. And then 7 times 4 would give me 28. Okay, so because I wanted 4 per each of the different sections. So number of ribs minus 1 is the number of sections, and the number of panels per section. Then finally, the number of panel points will always be, it's the number of panels we want to generate, but we have to add 1, because we have that thing where the number of, we need 1 more line to kind of enclose it. So if there were 24 panels we wanted to generate, I actually need 25 lines. And I hope that didn't get too awfully confusing in there. Okay, but I'm going to divide those curves up by 25, transpose them, put the splines in there, and ultimately, that's how I got all these different points. So with all those different points, what we said is, hey, when it came time to go through and do that flattening completely, okay, for putting the number of panels in there, okay, it was really to feed in this number of points instead. Okay, still flatten it, reverse it, make the quads out of it. So the rest of the logic's just the same. It's just that as opposed to being just the number of ribs, okay, we actually have the new number of like line divisions between all the different kind of panels. Okay, and all that ultimately yields all these different little panels in here. Okay, let us pause there, because I know there's a lot going on in there. If you can, at a high level, just sort of understand that we're subdividing what used to be these big chunks between the ribs into 4 smaller chunks, and then placing the panels there instead. It's all just, again, manipulating X, Y, Z points to create the number of points to give us all the quads, the corner points. Okay. What I would love to do now for you all is actually go ahead and take our break right now. Okay, and while we're doing that, I'll clean up my little model here a little bit. But then we'll finish this off by just saying, great, we have all these different panels that are all hanging around in here. They're all universally spaced, or the openings are the same. There's no color distinction. Go through and add that last little bit of kind of pizzazz to it to go through and get this thing to respond to the sun and things like that. And while we're doing that, just so you know, what I'm going to do is, as you're breaking, delete all that, because again, there was these two different instances on top of each other. Okay, and I'm going to regenerate that as we're at the break. Okay, so let me pause over here and I'm going to see where you guys are. Oh, why did we reverse the script? It's actually just to go through and put the panel points into order relative to how they have to be for placing the panels. Oh, I guess that these panels are fairly omnidirectional. They could probably go top to bottom and left to right versus well as left to right and top to bottom. So, you know, yeah, I pulled out the reverse, honestly, because I saw an example that I was using as the basis for this in terms of reversing the order. But a very good thing to do for Henry would be to go through and just, you know, flip them around, really take out the reverse and see what the effect is. See, if my suspicion is that it still would go through and map into points. They might be upside down and flipped. Something like that. But that's something for us to test. It really is just about getting those back into the precise order so that when we try to quad them, they'll be in the right order for quadding. So I'll think about it a little bit, see if I can come up with a precise answer about really, you know, how reversing the order, you know, puts them into the right order for creating the quads the way we want to map the panels to them. So there's a partial answer, but hopefully that'll get you going. Okay, let's go ahead and do this. Let's go ahead and break ourselves. It's a start. I owe you a better answer than that, but it's a start. So you're most welcome. Okay, let's break for 5 minutes here. Come on back if you can at about like 10, 13, 10, 15, right in there.